Hi everyone, I'm Kamal Jirala. I'm a geospatial engineer and I'm gonna show you today the digital engineering process using 12D version 15. We'll start with the agenda. We've got today the digital engineering overview. We're gonna go through authoring 3D objects. Then we're gonna go through linking the tabular data with the digital model. And we're gonna go through a quick demonstration. So what is digital engineering? It's all about collaboration and integration of systems. So digital engineering is not just the BIM model. It's more than that. It includes asset data, time data, the cost, the document management. It's all linked to the digital BIM model. So this is an example of system integration in digital engineering. We've got the GIS, the survey, work as executed BIM, and the quality system. So all these systems, they all make up the digital engineering process. It's not just one system or one data silo. It's all combined to make up the digital engineering. The digital engineering requirement, it's normally a document you get from your client and it outlines what need to be delivered. As an example here, there's a delivery of graphical digital construction model, which is the work as executed. It includes survey points, line surfaces, boundaries, and 3D objects. And we have a quality system, like we call it the non-graphical elements to the 3D objects, and a GIS deliverable. The digital engineering execution plan, it's essentially a document that you write to response to the requirement. On the right hand side here, we see this is a plan template. Normally get it from the client, and you write exactly how the DE implementation gonna happen in your project. This includes, of course, the common data environment, the CDE, and all your softwares you're gonna use for your project. So we have an important question here: why we need to use work as executed BIM? Well, because we first planned the project using BIM, we design it, and then we build it and we operate. So if the client gets only the design BIM, it won't be a reflection of what being actually built there. That's why we have to give work as executed BIM. The common data environment, it's coming from ISO 19650. In this environment, the digital engineer have to outline all the states of the data. We've got the work in progress state and shared state and the published state. And this is an example how you sort of put all these systems together in one system. So if we look here at this chart, it starts with the survey data, then it goes to the work in progress environment using 2D synergy. We've got the shared environment. It is in 2D synergy as well, and the published environment using Propeller and a cloud data management software like Aconex, then goes to the client. And we see how as well the archived state, which is again in 2D synergy. So 2D synergy can work as your whole common data environment in one place. So in here we see the spatial deliverables, which are like all sort of data that has spatial content. There's another type of data that's coming from engineers and workloads and quality systems and asset information. It's all as well going through this common data environment. So about authoring 3D objects using 12D model version 15, we've got this new panel, which is essentially you give it in here the boundary polygons of your lots and the two tins. So you get the existing tin, which is the bottom surface of your tri-mesh, and the new tin, which is the top surface. This is an example data I made up. We've got here the tri-meshes, and you sort of see how all these pavement layers come together. Just to demonstrate, so these tri-meshes, they're not all continuous objects. They're really broken up to lots. Like for example here, lot 1, this is your lot 2, and this is lot 3. And that's why we use the lot boundary polygons to dissect these works as executed BIM, and that's the main reason. And this is how we link it to the tabular data. It has to be dissected into lots. So linking the tabular data or the quality system or whatever data you've got into your project, you need to create these polygons, which are the boundaries where you define these lot information. Then what we do, we create all these tri-meshes, then we cut it using these polygons. Then we name, the next step, we named all these tri-meshes with the workload identifier. So this is a graph that shows how this all works. So what I did set up is I have a link to the SQL database, and I read this data through Python. Then I make this dynamic chain, and this dynamic chain get read into version 15, then creates all these boundary polygons. Then we export it to IFC, then goes to Navisworks Manage. This is my my code, like just an example code, like how you would implement some Python code to create the chain. It's really not complicated. It needs some awareness of programming, and this can be replicated with 12DPL language. So how we link this tabular data with the digital model? Well, this is one of the ways you can do it. You can name the tri-mesh with the work lot number. For example, here we've got work lot number 1, and this work lot number 1, on the left hand side, you've got the data, tabular data, like it can be Excel or SQL, and it has the same work lot and all the associated information for that work lot in that database. Then what you do through data tools is using data tools in Navisworks Manage, and it will combine the tabular data with the work as executed BIM. So version 15 versus version 14, as you can see, once we introduce Python and the dynamic chain, and once we introduce the tri-meshes, like the tri-meshes from 10 to 10, you get here 100x faster procedure. Like in the past, we used to do it on Civil 3D, which is like you take one work lot and two tins and make that manual procedure work lot by work lot. And if you get a small project, that's not a problem. But when you got like a massive linear project, it will be like fairly complicated. That's why using version 15 with the chains and the new way of creating the tri-meshes, it's much more faster. All right, we're gonna start with the demo now. I'm not gonna go through like very deep in the technical details, but I'm gonna show you how this all works. So we've got here the code to create the polygons. It's based on the data science module called pandas. What this sample code really does is read an Excel file that replicates a tabular data or SQL. You can modify this code to whatever tabular data you've got. And once I run this code, I've get these chains, and just to put this perspective, this code just generated 46,000 chain lines, like, and this how you can see sort of the power of programming. You can do 46,000 lines of chains just one hit, really. So if I wanna go to my 2D model project, so if we run this same chain, we read it here, you see all these create polygons, and this is the information from this chain came through from that Excel file. And you see here all these fields got populated with the information coming from the spreadsheet. So once we run this, you will get all these polygons, and you see here it's coming all in layers. If I want to click on one of these polygons, so this is a sample polygon. We got the name of it, as well as you can like customize the colors. I customize it here. If the polygon is green, that means that work lot is closed. If it's a blue color, that means it's planned. If it's just yellow color, it's just open and it's still work in progress. Once we get all these polygons, that gonna cookie cut all the tri-meshes. I'm gonna go to my version 15. So I've created this another chain here that creates all these tri-meshes. I'm gonna show a sample here. Layout file. So for example, we've got capping material. If I read this, and you will get this panel I was talking about before. And what I did, I gave it the bottom 10, then the top 10. Then I created the bottom 10 and top 10 attributes, and I gave it the polygons that we generated from that Python chain. And once you run this using this chain, you will get all this in one hit. So that's how it looks like. This is just sample data. And you sort of see here how this the tri-mesh pavement layer is cut on that lot polygon. If I zoom out, you will see. So we won't need to model each tri-mesh separately by using the chain and the polygons. It can be done in really one hit. So once all your tri-mesh is done, what you need to do is export that to IFC, and I have here this another chain that writes all the tri-meshes in separate files. And once you finish all this, if we go back to we go to Navisworks Manage, and you sort of see here the BIM model, which is really, if you look at it, it's the files we exported from 12D, and this is how it looks like. So now we need to show how we link all these tri-meshes to the quality system. In data tools, what you do is, for example, you want to link that quantities table to the work lot. You would go here and you essentially point Navisworks to that spreadsheet, and you put your SQL query and define all the attributes you want to see, and that's it. So what we can see here, these are the tabs that coming from the spreadsheets, and you see all these attributes linked to the BIM model. If I want to go through here, I'll just zoom out. Just trying to zoom in. All this output, it's just been done by 12D version 15. You can see here all the layers and all the excavation lots, and it's like kilometers and kilometers, and it can be done really fairly easy and quick. So recommendations, I really advise that the person who's looking after the DE to start first with the DEXP, Digital Engineering Execution Plan. It's the most important document gonna be in your project. It outlines all how you're gonna build this digital model and deliver it to the client. As you see as well, I've used a few diagrams to show a complex process, and it's easy really to show it to non-technical people so you understand what you're doing. The third thing is use programming. As you can see, I've automated making all these polygons in one chain. Finally, I want to thank everyone for their contribution to this process, and I hope I see you in the next 12D farm. Thank you.